And speaking of sharing some knowledge, a great talk on building a soft phone for scale by Conrad.
Thank you. Yeah, so today I'm going to be talking to you about building a soft phone. This is our little journey so far. My name is Conrad de Wet. Company is called Siperb. And I'm going to open with a quote. This is from Sam Altman. He said it a few times. Essentially, he's just saying that AI is going to make it possible for one person to build a billion-dollar company. So, show of hands. This is a bet. Does anybody think it's possible? Billion-dollar company, one person? The question really, to me, was, do we really want to make a one-person billion-dollar business? I don't think it's a very good idea. In fact, I think it's really quite a bad idea. Some of the reasons, well, I think you have an incredibly high reliance on a single individual, not a very good for a succession plan. I think you tend to believe your own arguments quite a lot. Easy to agree with yourself. It is, of course, easy to give up. And it's probably quite boring. So there's Sam at this table. But it did get me thinking, you know, if I wanted to build a business for the future, you know, what in fact would it look like, taking into account, you know, AI and what it could do for a business now and in the future. So I like to structure it as such. I would make it trust-owned, certainly not owner-operated, although that's something that often takes a little while to get there. I had the number 8 in my head, 8 humans, sort of as a panel, with any number of artificial intelligence behind that. I think a businesses that we make today should be globally scalable. So that's sort of some of my key points there. What would we make? Well, for me, obviously, it was quite simple, but I wanted to build and provide the service of a soft phone with the built-in proxy. And I believe in the WebRTC principles. I believe that calls should be encrypted and the signaling should be over a TCP link. So that was something that was important for us. How would we do it? Rely heavily on AI. I wanted to build a mobile first, but not mobile only business. And I wanted to build an application which had a single user experience. That single user experience, I'm going to go into a bit of detail now in a sec. And I want to build a business for scale. Goes without saying for today. So, back in 2024, after finding myself a little bit stagnant in the browser phone project, I saw browser phone early on today. I think it was Diego. So it's a popular repo. I find it popping up in a lot of places. But for me personally, I think I'd got into a little bit of the Sam Altman problem. And in March 2024, I hired some developers, sat down, we formulated a plan. We wanted to build this as a product and as a service. So I'm going to take you through today 3 sections of the business: the development, the tech stack, and the support. So, you know, being a business that's designed to have a small number of people and sort of working quite largely with AI, it meant that we took different decisions in our development stack and our tech stack and our support environment. So one of the things that we wanted to achieve was that this idea of a single user experience. So it meant that we wanted not just a similar user interface across all the devices. We want actually the same user interface. We wanted to present the same UI on all the devices across all the platforms. And we did this using one technology which is actually better than anything else we came across. And it's actually quite simple: HTML and JavaScript. It by far was a better, or by far a more similar experience across all the different flavors of Android, iOS, browsers, desktops, applications. So like in the example of those 3 screens below, it's actually the same HTML being rendered across all these devices. So I think it's something like 9 different platforms in the end of the day. What we used to achieve that, Tailwind. Tailwind is a fantastic toolkit that allows us to develop the styles and patterns for the UI. There's a bit of an example underneath. You won't be able to see that, but essentially the way we did it is we built a single HTML document that populates all the user interface, okay? Separating out UI from code. I think this was a very old principle from the C and C++ days, where you had your UI completely separate to your sort of business logic. And over the years, it's sort of mixed in. You get sort of more React-style looking interfaces or code nowadays. And for us, we wanted to separate them out again. So HTML is a separate document. That's all the user interface elements in one space. Then we have our JavaScript core. So our JavaScript core ended up looking like this. And it allows us to have one team, one focused skill set for the entire product. Starting in the middle there, we've got the BrowserPhone SDK, which is the sort of evolution of the BrowserPhone. That's the GitHub project. Wrapped in a thin layer on top of that is what we call the WebPhone SDK, which kind of gives our core arms and legs and various appendages. That kind of makes a phone, but it's not a full product. So then what we call the Siperb layer on top of that is now the branded layer. That's the product that we sell, and then that's what people interact with. Anybody could sort of enter in at any one of these layers if you really wanted to. And then the product that we sell and everybody sees mainly is the Siperb layer. And then just to illustrate, that's the layer that's deployed down onto browsers, onto desktop applications and mobile phones. And sort of how that kind of looks, if I illustrate it on a mobile phone, for example, you know, we layer down a web view, which renders the first layer, and then the Siperb layer, and then, of course, the actual phone integration layer, which would be something like CallKit for voice calls, push notifications, things like that. That's the other layer. So it's a kind of neat layered approach, but it does mean that we rely on WebView. WebView is an interesting one because we end up in this WebView land. Operating systems don't like us. They tend to unload you very easily. We can achieve the same kind of performance. I mean, it's not a game. We're not doing 3D rendering or anything like that. So the user performance is fine, and the scrolling is just as good. So we don't really have any problems like that. But it seems that operating systems just end up unloading you for memory conservation. So we've just got to handle that a little bit more carefully. It also means that sometimes it's another step in to communicate with your JavaScripts on that layer from the phone layer, but you don't have a lot of integration, a lot of interaction between the two, so it's generally fine. We find, though, that essentially the performance and the ability for us to deploy code is it sort of makes up for any of these disadvantages. But I just wanted to sort of pause a little bit on the development side. is it, a couple of months ago it was tab, tab, tab. We work in our code editors and produce code magically. Now we're just given a prompt, right? Make me an app. So, it sort of made me sort of think a bit, building this future business, to say, but what does it mean to write code now? What is the value of code when somebody else can just come along and make me a soft phone, right? Easy. So what it meant right from the beginning, in fact, even in 2024, we had this idea that it's not so much the code that we write, it's actually about the service and the infrastructure that we provide. That is what makes us a business. So just in sort of like summary, I feel like in the future, companies would be sort of judged, or companies are going to be successful based on, how well they integrate. It was API, now it's MCP. Kind of just imagining a future, you just ask your agent, make a call to mom. It's not an app anymore, really. And the AI might find an MCP that's a good route and a reasonable rate and send your call out through there. So, that's probably a little further down the line, but the idea is that, the value of the code drops with AI, and the value of your service and your infrastructure increases. And for us, that was something quite important. So we really did need to create a tech stack. So that means going onto the tech stack, this is what we did. We realized that obviously, this almost brings in a whole new department when you're putting down equipment, okay? If you, the usual story, if you put down one server, you need to put down two, right? Failovers, all that kind of stuff. We speak in arrays now. We don't have a server, we have a server array. So in our hosting objectives, one of the things we wanted to do, because we could now, because we're providing it as a service, we can get the passwords out of the browser. And that was something for WebRTC that's always been a bit of an issue. We can hide your IP address, right? It's the proxy's IP address, not yours. So these are two things that we could do. And then, of course, we could grow the server-side features endlessly, right? We add on AI, integrations, all this kind of stuff, recordings, transcribing, all these kind of things can happen on the server side. How we did it? We use Amazon Web Services. I've pretty much been part of the Amazon Web Services for years, and I've just stuck with it. We use serverless as much as possible. We have a handful of EC2 instances, but mainly use Fargate. So this is the tech stack. This is what it looks like. We use OpenSIPs as a proxy. It works with your Asterisk box. So there you can see in orange on the left, your Asterisk box either in your office or in the cloud, hosted, etc. We sit in the middle between the client, the softphone client, and there's two registers. The one register, which is the register between our SBC and your Asterisk box, that's a permanent registration. And then when a call comes in, then of course we can alert your instance, say it's the mobile app and it's in your pocket, we send the VoIP push, there's the call, or if it's in the browser or if it's in the desktop app, it's all the same. Another thing that we do in that is that we obviously provision down your details. So you just launch the app, all the details about who you are and all your credentials, that kind of thing is all pulls down for you. So you don't type it into the application. All right. So, you know, when you make these systems, you think this is how it should work ideally, but then of course, everybody has their own sort of ideas. But yes, there are a lot of local Asterisk instances installed in people's local lands. So one of the things that we needed to be able to accommodate for is people's Asterisk boxes on their local lands. And so we brought in something called the WebSocket registration mode, which now just bypasses our proxy. Okay, it doesn't go through us. It unfortunately means your passwords are now in the browser. They provision down the passwords, but they're your passwords, so they go down to the device. But the call is made, the WebSocket connection is made directly with your Asterisk box. And as of fairly recently, we can now do that on UDP, TCP, and TLS if you're using the desktop application. And we accept self-signed certificates on the WebSocket connection as well. This doesn't obviously work on mobile devices. There's just, mobile devices are just not, let's say, online enough. They'll be easy to switch over to 3G, and then of course your Asterisk box in your office is just as unreachable as it was just now. So it's not an option for mobile devices, but for the desktop and for the web application, that is an option for you. But every business is going to have this problem eventually, right? You need support. You have customers, and as I described earlier on, we're a small team, less than 8 people, and we need to now support customers. So how do we support customers? We're not going to have call centers. We're not going to have people around to take your call and hold your hand through these things. So we looked to AI. But we had some fairly strict objectives of what we were going to do to solve our support problem with AI. Now, one of the things that I learned in business many years ago was that it's very important to focus your time and your efforts on the things that make you or your business unique. You know, if you sell coffee, you're not going to spend your time developing an invoicing application, right? Just use one. They exist. You focus on selling coffee. And the truth is that, you know, even with Microsoft Word coming out many years ago, people were probably asking the same question. Oh, do I need to now become a Microsoft Word expert in order to work in your company? Well, yeah, you probably do. You probably need to be able to use Word. If you pitched up today and said, yeah, my typewriting skills are great, you're not going to get a job. So we applied this to our support and said, do we need to take on support? Is it something that we can outsource to AI? Is it something that we need to own? The truth is that we felt like with quite a bit of work in AI, we could get it to be better than an actual support person. So our objectives were this, that we wanted to be able to answer customers in real time, right? No queues, no waiting, no nothing. Get your answer straight away. We want to be able to answer them on multiple channels: email, text, chat, and audio. All right? And we wanted the same agent, right? We want this agent with all the information at its disposal across any of the channels. So if I emailed in and said, hey, I just sent a WhatsApp message, did you get it, or whatever the case may be, the AI can cross over the channels. And we felt like over time, this would build up what we call the customer digital clone. So armed with all of this information across your different channels, the AI agent becomes this digital clone, but of the customer. residing in our environment. It has access to the knowledge base and the website, obviously. It can access the customer's admin control panel. It can access transcripts, text, call history, and support tickets. All right? And over time, this customer digital clone actually becomes far more useful at answering questions with this customer than we ever could be. We just don't have that length and breadth to know every text message that you sent in, but AI can. Know every email that you ever emailed, AI can. So what it turns out we'd be able to do is, in fact, ask the AI agent, not the customer, give me a customer engagement score. How's it going with customer X or Y? They'd know, all right? We'd ask the AI, is there any outstanding items with any of the customers? Do we need to get back to anybody on that? AI can give you that. Anyway, as things can progress, we can even get it to send emails back to the customer periodically, follow up, ask them how their kids are, all that kind of stuff, although we've put the handbrake on that one. I think that might be jumping the gun. So what are the channels that we built? Well, first of all, we're doing this all through OpenAI. It provides everything that we need, and out the box, we use the ChatKit SDK. That was a fairly straightforward implementation. You can see in the middle there, that just drops into your website. It's tied in with a vector store, which is your sort of knowledge base, and the sort of text prompt and response system. It keeps the history all by itself, because if you use the agent builder in OpenAI, you've got to remember to use your conversation history, your conversation ID, because otherwise you don't actually have history. So we store, the only real thing we actually store is what channel you're communicating on, a reference to that channel. So if you called in, your caller ID is your reference, the channel, audio, and the conversation ID. So each channel is its own conversation ID, but the agent can go across channels. But you'd have to ask it. You would say, I called in yesterday. And then it could say, let me go and have a look at your calls from yesterday. So the other channel we have is Telegram. That was a pretty easy one. Just add a bot and tie in the callback URL to a Lambda function. The same with WhatsApp. WhatsApp's got a couple more hurdles you have to go through in order to achieve that. But they also have very similar sort of end product where the callback URL is initialized on every message. This lands up, in our case, in Lambda, and from Lambda it goes through to the OpenAI prompt and response system where we keep the conversation ID going. So endlessly, the conversation just keeps building on itself. Even if you come back later, you just continue on the same conversation on the OpenAI side. And then, of course, the last little piece in the puzzle with that, I don't know if you can see it, but there's a small little call button on the top right of the WhatsApp message. So we can call in using WhatsApp. All right? So it's text and audio. And as it turns out, last year, probably about the middle of last year, WhatsApp opened themselves to SIP termination, and so did OpenAI. Go figure. So all we do is take the SIP call from Meta and send it in to OpenAI. I'll show you what that looks like in a sec. But in order to achieve that, we have to set up audio calling. And you use a special agent inside OpenAI called the real-time audio agent. It configures slightly differently, but it's very similar. We use Asterisk as a sort of a stopgap in between that allows us to utilize the back-to-back nature of WhatsApp, of Asterisk. So the call terminates on our Asterisk box, and a new leg is then onwards dialed into OpenAI. This is what the config, this little snippet of what the config's going to look like. I'm not sure if you can see the dark blue there, but so your pjsip.conf just sets up a fairly straightforward trunk, really. Only thing unique is that we have to use TLS. They want you to use TLS to OpenAI. You don't use WebRTC, just WebRTC is no. I have allowed Opus. I can't remember if it has to be Opus, but I have it in the list there. I generally use Direct Media's no, Force R port, and RTP underscore symmetric is yes. It's pretty much a default for me. I didn't really ever try anything else. And there's the contact where we use sip.api.openai.com. So that's the configuration. In order to reach OpenAI, also fairly simple, just dial. You dial the project ID. So the project ID is given to you inside the console of OpenAI. You dial the project, it's proj underscore and then the ID of your project. And you can see I'm referencing the OpenAI trunk from above with a timeout of 30 seconds. All right, so how that all fits together and how we build it for scale. I mean, we are at a scale conference, so let's talk scale. AI agents are great, but what happens when you have many calls? All right, $1 billion business, going to take a couple of customers. Okay, so for this we turned to Fargate. I had been using Fargate for a couple of years before that. Fargate being a Docker runner. It's a native AWS product. I like it, and it does what we need. So again, we didn't really think too far out. And I like working with Docker, with Asterisk. I know this is a bit of a funny topic for people. There's a lot of people think, no, you can't run Asterisk in a Docker, or there's a lot of problems with it. Ports often come up, but it doesn't actually work that way in Fargate. They give you an IP pair, that's a local and live IP address, and that IP address gets attached to your Docker instance, and it's up to you with your security groups to essentially secure that. All the ports are open. So UDP ports for media are not blocked. All right, so your security group is the thing that secures it, but essentially it's the thing that also keeps the ports open for media. All right? So we also like the CI/CD flow using Docker because we're not logging into any consoles asterisk -r, right? Okay. If your instance is running, it's running. Leave it alone. If it's not doing what you want, rewrite the Docker and press deploy. And that's it. So we tied in the deploy into the GitHub repo actions, and that gives you a workflow of edit Docker or your configs, run, test locally if you want, push to GitHub, pull to release, and your actions perform your deploy. You just sit back, relax. Deploy takes about 8 minutes, and you got a new machine. We build each time from source, so we do the entire installation process essentially from the GitHub repo. So that's our sort of CI/CD process with this. And And of course, the big question then is, what about IP addresses? As I said, you are working in Fargate. The IP address has to be known to Asterisk. So this is how it all ties in. So earlier on, I showed you that there was a TLS transport configuration applied to that trunk. So here it is. You would have to use a substitution in your run script in your Docker installation, and you set the Docker IP address to your bind IP. There you can see I've used port 5060 on the Docker IP address, and we use the external media address entry. So using external media address with your live Docker instance, not the local, the live Docker instance IP address, allows media to flow over. You can see the orange arrow at the bottom there. The media flows on its live IP address, and the way we've done this, which I can highly recommend, is that your local IP address is the one that you're using for your signaling. So in this example, I have the Asterisk box with its local IP address for signaling. The invite arrives there, and the live IP address for the media. Means that the ports can be open with relatively little risk. So a call flow, starting from the left, through any channel, maybe a cell phone, PSTN, WhatsApp, as we said, or a normal VoIP call, comes in and it lands on our SBC. That's our live IP address, exposed to the world, well protected server. It's an array of instances. The invite arrives on that box. Now we have some routing logic. Obviously, not every single call goes into an AI agent, so it'll follow the routing logic, and if it is for the Asterisk array, it finds an available Asterisk server. So you will have a lookup process. Remember, of course, if you want to replace Docker instances and things like that, you'll have to drain them of existing calls and connections. So you'd have to find an available Asterisk box that I'd leave up to you to work out the mechanics of that. But the invite arrives on the Asterisk box on its local IP address. That is then the second leg, the B leg. Remember the dial instruction in the dial plan dials through to OpenAI, referring to the project. The call establishes and media flows from OpenAI onto your Asterisk box on its live IP address thanks to the external media address, and then back onto wherever you came from. Okay. Now, if you did that, you would land up in a situation where you wouldn't actually get a call, because there's a couple of things that come into this. This call flow is a sort of like a made-up version of what you saw earlier on. Rather than using anything new in Asterisk, no WebSockets, no CHAN audio, no, what was it, Snoop channels? Yeah, nothing. This is standard vanilla Asterisk. In fact, it could be whichever Asterisk you wanted, so long as it supports the TLS connection. Because what we did is we created a node service that runs on the same box as the Asterisk instance. And the call flow would go as follows. It will arrive on the Asterisk box, you create the new leg, and the invite goes through, as I mentioned earlier, into OpenAI. In return, OpenAI then call your registered webhook. That registered webhook is assigned, in our case, to a Lambda function. Now that's quite important. Our Lambda functions are always available, highly available, and they can perform any number of tasks. Get into a database, find customer history, all that kind of stuff. So that's exactly what we do there. At that Lambda function, We can collect call history, we can collect all the customer information based on the caller ID or whichever identity you want to use. We store in DynamoDB, and we return that back to the Lambda function. But Lambda has got a hard cap, 20 minutes, that's it. You're not running any scripts longer than that. So the truth is, you have to be answering the call and be on your way. So we get the caller information, and we then do a post to our own service. So that's the node agent service, because one of the parameters that we pass ourselves is which instance of Asterisk is running this call, because I obviously want to give this information back to the instance of Asterisk that's actually running the call, because then I can perform functions on the call. I can use any number of interactions, REST APIs, all that kind of stuff in order to control the call. So the call information is then sent back to this node service. I called it agent service JS. You can call it whatever you like, but essentially it's a small little express service that's running, waiting for a post. It receives this post. The next step that you have to do, because of course up until this time the call is not in fact answered yet, right? You have to post back to OpenAI's REST API. You have to post back with call ID and /answer, right? That's the signal to the user that your call is answered. You get back the 200 OK at that point. All right. So that's our answer. But at this point in the call, it's answered, but the agent says nothing. Okay. So what you need to do now is immediately after answering the call, you need to establish a web socket. And that web socket is your call control web socket. All right? I think we heard something similar earlier on. But essentially, you can reference your call ID on their system and feed it transcripts, feed it information, and get back things like transcriptions, transcription delta, which is each individual word, and all that information passes between OpenAI and your own service. So you have everything in control. You can control the call, and you have the transcriptions. You also run, inside that service, your tools. So you define your tools inside OpenAI's console environment, where you would say, for example, I want to get previous WhatsApp messages, right? And you run your tool from inside your agent service. So the agent service would be initiated. This user wants to see his previous call history or something like that. And that's where you would go and look up the call history. One of the things that I did for this agent was that I primed the agent with information. But timing is quite key here because it is a real-time call. So when the webhook posts the information to us, it doesn't contain too much information so that the timing is quite quick. And what happens is then, while the agent is saying, hello, how can I help you, all that kind of stuff, we use the WebSocket to pump in the call history and the context of the call. So it has what's called the instructions. That's just how the agent behaves. But I want to give the agent the previous interactions. But I don't want to give it to the agent before the call. That just slows things down. I want to give it at a time that is convenient. And we found the best time is when it's busy saying, hello, how can I help you, and all that. So that's a fantastic time to really pump in a whole lot of information. You can get quite a lot of information in there. So that is essentially how your agent works. That's what we built as a support agent. We're currently using this system now. It's live. And people are texting the agents, some people are calling, and it's got enough of the knowledge base to be able to answer the questions. The big key in all of this is actually to give it enough information. That's when you don't get mistakes. If you give it enough information, enough context, essentially that's when you get the best results. So, a bit nervous about this one because I don't know about the audio quality. But anyway, I recorded an interaction, and it's well worth listening to. So I hope it's going to come out, and I hope it's going to be loud enough. It was pretty close to this, but I did cut it for different purposes. Yeah, if you're just ready to kind of tweak the audio a bit there. What you're going to see is I call into my own agent. Obviously, I mean, that's unrealistic because it's really for WhatsApp, but I have a route into my own agent, and it's going to demonstrate its knowledge in the knowledge base. That's the first thing. Then we're going to get back to a couple of things like the call drops, and I call back, and it demonstrates that it can pick up where we left off. I mean, calls drop, right? And you don't have to explain yourself again to the agent. What else does it do? Oh yes, I use a tool call to open a support ticket, and then I call back again, and I inquire about the support ticket, but then I need to log in, okay? And that login process, it takes you through the login process, which it's well trained how to do, and then after the login process, it can read and feed back the information that it had off the ticketing system, which is simply Zoho. So here we go.
Hi, this is the Siperb AI assistant. How can I help you today?
Yes, hi. Does Siperb support Asterisk PBX?
Absolutely. Siperb fully supports Asterisk PBX. You can connect your Siperb Softphone to an Asterisk system using the Siperb proxy or via WebSocket registration mode, depending on your setup. Whether your Asterisk PBX is publicly reachable or on a local LAN, Siperb can bridge the connection and give you a seamless experience.
Can you tell me how I connect my PBX to the softphone?
Of course. Connecting your PBX to the Siperb Softphone involves creating what we call a connection. This connection acts as a bridge between your PBX and the softphone. There are two main options. If your PBX is publicly reachable, the Siperb proxy can sit in front of it. You'd set up an inbound or outbound connection in the admin control panel, found in the softphone settings menu. If your PBX is on a local LAN behind a firewall, you can use WebSocket registration mode. In that mode, the softphone registers directly to the PBX over the LAN. Would you like to walk through the steps for your specific setup?
No, it's fine. Just tell me something. Using connections, does my Asterisk PBX need to support WebRTC?
Good question. Your Asterisk PBX doesn't need to support WebRTC natively. That's exactly what the Siperb proxy is for. The proxy handles the WebRTC side, translating it to SIP for your PBX. So your Asterisk just needs to support standard SIP. The Siperb proxy bridges the gap, allowing your softphone to connect via WebRTC while your PBX Hi, this is the Siperb AI assistant.
It sounded like we got cut off there. What were you saying, sorry?
Hi again. Sure, let me recap. We were discussing how the Siperb proxy works as a bridge, so your Asterisk PBX doesn't need to support WebRTC itself. The proxy translates between WebRTC from the softphone and SIP for the PBX.
Okay. All right. You know what? My Asterisk PBX needs to have a TLS connection. Does Siperb support TLS?
Yes, absolutely. Siperb supports TLS connections with your PBX.
You know what? I would really want somebody in your support department to confirm this. Could somebody do that for me?
Absolutely. I can open a support ticket for you, and our support team can confirm all the details about TLS support on your Asterisk PBX setup. To open a support ticket, I'll just need your email address so we can pass this on to the support team. Could you please confirm your email address for me?
It's conrad@siperb.com.
Could you please tell me the subject and a brief description of the issue or question you'd like to include in the ticket?
The subject is whether Siperb offers support for TLS connections.
Got it. The subject we have is confirm if Siperb connections support TLS transport. Now, could you give me a bit more detail about your setup or what you've tried so far, so we can include that in the description for the support team?
Well, I would just want a human support person to confirm that TLS is in fact supported with the connection system between Siperb and my Asterisk PBX.
I've opened the support ticket for you. The support team will follow up shortly to confirm the details about TLS support with the connection system and your Asterisk PBX. If you have any more questions in the meantime, feel free to ask. Your support ticket has been opened successfully. The ticket number is 333. The support team will get back to you soon with the confirmation about TLS support. If anything else comes up, let me know.
That's the Zoho system.
Hi, this is the Siperb AI assistant. How can I help you today?
Yeah, I'm following up about the support ticket that I just raised with you. Is there a response to it?
Thanks for following up. At the moment, you're not verified, so I can't check the status of your support ticket directly unless we verify your identity. If you'd like to proceed, all you need to do is go into the settings of your Siperb Softphone, enable audio call support, and generate a PIN. Then you can share your email and PIN with me, and we'll get the latest update on your support ticket.
Okay, I've done that. My email is conrad@siperb.com.
Thanks, Conrad. Now please provide the PIN that was generated in your Siperb Softphone so we can complete the verification.
It's 60888.
I'm validating your email and PIN now. This will just take a moment. Your identity has been verified successfully. Now I'm retrieving your support tickets, and we'll have the latest status in just a moment. Your most recent support ticket, ticket number 333, is currently open. The ticket requests confirmation from the support team on whether TLS is supported between the Siperb connection system, the Siperb proxy, and your Asterisk PBX.
Yes, that's the one. You know what? Is there a reply to it?
I've checked the latest details on ticket number 333. As of now, there hasn't been a response from the support team yet. Actually, there has been a reply added now. It looks like the support agent responded and confirmed that TLS is indeed supported. And they even mentioned hoping you're enjoying the Asterisk conference. The ticket is still open, but the confirmation is there. If you need any further assistance or have follow-up questions, just let me know.
All right, so there you go. That's essentially the... Oh, wrong one. Yeah, so that's my, my support agent for me, working hard for me there. If you're wondering, there's a couple of breaks or mispronounced words or something like that. I still think it's quite a good feat. That call was made from the bottom of Africa in Cape Town through to the UK. And from the UK, that was where the Asterisk box is. And from the UK through to OpenAI, wherever OpenAI is. And so for that kind of distance, to get that kind of low latency, I think that's something really worth considering. A lot of people are doing, or a lot of people are battling with latency, but when you SIP dial directly into the OpenAI structure, it does the transcoding, does everything all for you there, and you still maintain all the call control with the WebSocket, and you can get your transcription fed to you live in Delta, and you essentially get a very similar experience. Okay, that's essentially, that's it. That's information about Siperb on the link there, and that's the Telegram bot over there, the QR code if you really want it. Thank you.
Conrad? For one or two questions before we move on? Yep.
Conrad, thank you very much for that presentation. I liked the way that you interrupted the bot. I thought that was really good. But I had a question on how to handle the ums and the ahs and the pauses and the human element. What did you go through, or what have you gone through when somebody says, oh, hold on a minute, let me go, and then comes back, and all those human things.
Yes. So we started the turn detection with a simple voice activation. I think that was the default in the OpenAI infrastructure, and then it does actually have another option, which is sentiment, which is then where it's listening out for you ending your conversation or your sentence. I tested it a bit. Obviously, didn't want to put it in that video, but things like clapping your hands while you talk, or while it's talking, moving, squeaking your chair, things like that, it doesn't interrupt it. The only tricky one is if while it's talking, you say, oh, okay. And, it's quite natural to encourage people when they talk. You agree with them, or you say, okay, cool, things like that. And it doesn't really handle that very well. But I think these things are getting better. So it's really the kind of thing where I don't really want to take that architecture on. I'm very happy to go with what is available. And by changing from voice activation, which was terrible, anytime you squeak or make a single noise, it just jumps in. And so going to sentiment inside the settings, inside OpenAI, was absolutely wonderful. It made it much smoother, made the conversation much more consistent and more human-like.
Good question, yeah. Anyone else have a question for Conrad before we move on to the next session? Oh, yeah, Mark.
Hey, yeah, so obviously you guys are a soft phone company, but have you thought about marketing this AI that you use for tech support?
It was quite funny because I've done a lot of this in Claude code. I mean, I vibe coded half of it. So the whole time it's prompting me, the whole time coming back and says, in qualifying questions in the beginning, it's saying, is this a product? Are you making this as a product? Are you sure it's not a product? No, it's not a product. We just want to make our own business more efficient.
That's a great origin story for Asterisk itself, right? I mean, wanted to make own PBX efficient for Linux support services back in the day, and that's what we got.
One thing I would say is that the style of architecture of that system does mean you take a lot of the technical burden off yourself. There's no WebSocket audio packet stuff. You simply dial straight in, so it simplifies things a hell of a lot, and you get an audio agent in minutes.
Hey, thanks for sharing, Conrad. It's great to see. Hopefully everybody can benefit from that. Thank you again.